Hello guys, so we are going to continue the discussion with respect to statistics, and in this video we are going to see about a new topic which is called as scales of measurement of data. Already in our previous video we have seen the types of data. Now you should also know how do we specifically measure this data and record it, right? So what is the scales of measurement of data? So here you can see the scales of measurement describes the nature of information within the value assigned to a variable. Whenever we create a variable, let's say with the help of Python programming language, and let's say that if we insert some kind of information, this scale of measurement describes the nature of the information, right? So considering this, there are four primary scales of measurement, which we are going to discuss completely in depth. That is about nominal scale, ordinal scale, interval scale, and ratio. Okay. So we will try to go ahead and discuss one by one all the specific topic. But again, understand what is the definition of scales of measurement. It describes the nature of information within the value assigned to a variable. Okay. So let's first go ahead and talk about nominal scale. So first one, we will go ahead and define about nominal scale. Now, whenever we discuss any topic, first of all, we will go ahead and write its definition. Okay. So definition of nominal scale is nothing but this scale classifies data into distinct categories that do not have an intrinsic order. Okay, intrinsic order. So this scale classifies data into distinct categories. Now whenever you have distinct categories, that basically means we are talking about qualitative. We are talking about nothing but we are basically talking about qualitative or categorical variables, right? So this basically have data of type qualitative or categorical data, right? Okay. So this scale classifies the data into distinct categories that do not have an intrinsic order. So here ordering is specifically not there. So if I talk about some of the important characteristics, and with respect to this, some kind of example also I'll discuss. Okay. So the first characteristics is that data is categorized based on labels, names, right? Or qualities. Okay. So they are categorized based on some label. It can be names or it can be some kind of qualities. Second point. Okay. These categories that are defined in this kind of nominal scale, these categories are mutually exclusive. Mutually exclusive. Now what does this basically mean? Let's say I have a feature which is called as gender. Now in this gender, you can either have male or you can have female in a specific record. You cannot have male or female at the same record, right? You cannot have two values at the same record. So this is basically mutual exclusive. From both of these categories, either one value will be present at a time. Okay, it cannot have both the values just in one record. Third important characteristics is that no logical order among categories. There is no specific logical order among this kind of categories itself. Okay. That basically means there is no rank. Okay. Rank or ordering is specifically not there. Now let's go ahead and see some good examples. So here was just one of the example that we used. That is nothing but this. Just a second. No rank. I will just go ahead and delete this. Okay. And I'll go ahead and write it once again. So let's see some of the examples. Now, one of the example that I would like to probably say, let's say that I have something called as gender. Now with respect to gender, as I told you that you may have values like male or female, okay? And this will be mutual exclusive. The other important example that I can probably talk about is like colors. Let's say I have another feature color. This can be red, this can be blue, this can be pink, okay? So I will also define pink over here. So these are my other different colors. Now with the help of these categories, what all we can specifically do, right? When we are doing data analysis, let's say I have 10 people, okay? And 10 people, from the 10 people, I can say, hey, 5 basically likes red bike, 4 likes blue bike, and 1 like pink bike, okay? Now from this entire information, I can say, hey, 50% of the population likes red bike, 40% of the population likes blue bike, and 10% of the, I'll not say population, but sample, because here I just have a sample data, right? I can say, hey, 50% of the sample basically likes red bike, 40% of the sample population, sample data basically likes blue bike, and 10% of the sample data likes pink bike, right? So this kind of information we will be able to probably analyze, by using this kind of categories, okay? So here you can actually see some of the examples that I've actually mentioned. One more example I will go ahead and give. I will just go ahead and consider one example, which is like types of cuisines, right? So in restaurants, you specifically go ahead and see, hey, you have an Italian cuisine, you have a Chinese cuisine, you have a Mexican cuisine, right? So different cuisines can be used with respect to this also, right? But here, one important thing is that you have a qualitative or categorical data, okay? So this was about nominal scale. Now let's go ahead and discuss about the ordinal scale. So second one that we are basically going to discuss type is specifically called as ordinal scale. Now, as usual, we'll first of all go ahead with the definition. Now, ordinal scale, this scale classifies the data. This scale classifies the data into categories that can be ranked or ordered. So here ranking can be specified for this kind of categories. Okay. So let's talk about the characteristics. See guys, I'm trying to explain in such a way that you know the definition, you know the characteristics, and then you probably understand about the examples. Later on, a lot of practical applications or implementation will also be done. Okay. So here, one of the important characteristics is that data is categorized. Again, it is having a categorical data and ranked in a specific order. Okay. Second, the second characteristics is that the interval between ranks are not necessarily equal. Okay. Now let's see some kind of example. Okay. So one basic and simple example that I would like to talk about is, let's consider education level. So in education level, okay, let's say this is my feature. I may have something like high school. I may have bachelor's. I may have master's. Okay. Now, based on this education level, we can rank this, right? I may have one more category like doctorate. Now in my data set, whenever I have a data set, I may have this categories getting repeated some or the other way. Now, based on this category, I can even perform a feature engineering, right? I can even perform feature engineering wherein I change this specific data. Now my feature engineering, after doing the feature engineering, here what I will do, I will go ahead and apply ranks, right? Why do I apply ranks? Because I know as we do doctorate, right, more better rank is specifically given. So rank over here for high school can be given as 1. Let's say I want to give the rank in ascending order. Bachelor can be given as 2. Masters can be given as 3. Doctorate can be given as 4. So here I'm giving more importance to doctorate, right? So this is why I've given the rank in the ascending order, right? So here I'm saying, hey, maximum value I'll give it to doctorate, then less value I'll give it to masters, then bachelors, then high school. Because I know doctorate will probably have more salaries, something like that. So this is one example. The second example can be like customer feedback. So customer feedback, again, we can specify like this. Okay, here I will go ahead and write like satisfied, very satisfied, not satisfied, right? So with respect to this 3, I can again assign ranks to this. When I say very satisfied, this should be given the high rank, then satisfied will be given, then not satisfied will be given, right? So if I'm starting from 0. So this kind of ranks we can specifically give. I can also take one more example. So I can say, hey, socio-economic status. Let's say in one of the feature in my data set, I have socio-economic status. So here I have values like low, middle, and high, right? So here also we can assign some values. Low will be given 0, middle will be given 1, high will be given 2, right? Let's say if I am trying to design a policy for the government, right? So government, what they do, they change this rank to some other values, right? Let's say they want to create a policies that is more focused towards the lower income, then this will be higher rank. So I will say 2, 1, 0, right? So this kind of ranks can be specifically assigned. And this is about ordinal scale, right? And with multiple examples I have actually discussed. Now the third scale that we are going to discuss about is interval scale. So guys, the next topic will be about interval scale, which is the third type. First of all, we'll go ahead and see the definition. So here you can see the interval scale not only categorizes and orders, but also specify the exact difference between intervals. It also lacks a true 0 point. Okay. So let's go ahead and discuss about this, what exactly interval scale is. And again, just don't go with the definition. It is better that we probably go ahead and understand with characteristics and examples. Okay. So here, whatever data is, this data is ordered. Okay. Ordered with consistent interval between values. Consistent interval between values. Okay. Then the second important point over here is that it allows for meaningful comparison of differences. Then the third point is it has no true 0 point. Now, what does this basically mean? We definitely have to see with the help of examples. Okay. So let's take one of the example. So let's say one of my data is something like temperature. Okay. And temperature, this can be like in Fahrenheit. Let's say that, okay, I have a temperature with respect to Fahrenheit. Now, temperature with respect to Fahrenheit, some of the values may be like 10 degree Fahrenheit, right? 20 degree Fahrenheit, 30 degree Fahrenheit. Okay. Now, you know that when I have this kind of data, I can obviously calculate the difference. I can say, hey, 20 minus 10 is equal to 10, 30 minus 20 is equal to 10, right? I can basically go ahead and calculate it, right? And right now the differences between all these things, all these temperatures, right? Like Here you can see between 20 minus 10 is 10, 30 minus 20 is 10, right? So the differences is also same, right? Almost same. Here, when I say no true 0 point, basically means what? I do not have, see, if I have 0 degree Fahrenheit, okay? So this basically means no temperature at all, right? And this is not possible, right? Do you think this is possible? 0 degree Fahrenheit? It does not mean, like, it means no temperature itself, right? So this kind of value will not definitely occur over here. One more example in order to make you understand better. Let's say I have some IQ of students or IQ scores. Now here I may have values like 90, 100, 110, you know. Here we can definitely calculate the differences, right? I can go ahead and say, hey, the difference between this student to this student is nothing but the IQ is 10, right? When I do the subtraction of 90 minus 10, right? It's nothing but 10, right? And again, I cannot say, hey, this person has an IQ of 0. This is not possible, right? At least there will be some kind of IQ, right? One more example that I can take is about calendar years, right? Right now it is 2024, right? Last year, let's say it was the previous leap year, if I probably consider was 2020, right? Then 2016. If I probably do the difference of this, I will be getting 444, right? So we can definitely calculate the difference. Here also, I cannot say 0 year, right? It does not have a 0 starting point, right? No true 0 point itself. So these are some of the examples with respect to the interval scale. Finally, let's discuss about the fourth type of measurement of scale, that is nothing called as ratio scale. Now in the case of ratio scale, it is really easy to understand because you have understood all these things, right? Here, you can see that the first point that I will go ahead and write is that the order matters over here. In previously also the order mattered. Differences are definitely measurable. Previously also differences were measurable. But if I say, see over here, you will not be able to find, see when I say there is no true 0 point, here it contains a 0 point, right? It contains a 0 starting point, right? Now let's go ahead and quickly see some of the examples. So here I will say, hey, let's see. So I may say, hey, students marks in a class. Okay. So a student for a specific subject may have 0 value, 0 marks, 90 marks, 60 marks, 30 marks, 75 marks, 45 marks, right? So here, if I just go ahead and see in ascending order, let's say 30, 40, sorry, this should be 45, right? This should be 45. Let's say 30, 45, then I have 60, then I have 75, then I have 90, and before this I have 0, right? So here you can see it starts with 0. It can start with 0. Marks can be 0, right? I will also be able to calculate the difference. Let's say if I want to calculate the difference between this and this, I will go ahead and write 45 minus 30, which is nothing but 15, right? Similarly, I can go ahead and calculate the difference between 60 minus 30. So I will be getting a value over here. So differences are also measurable. There is also one more very important parameter, which is called as ratio. If I want to find out the ratio with respect to this particular marks to 30, so if I go and write 90 by 30, that basically means here I'm actually going to get 3 by 1, right? 3 by 1. 3 by 1 is nothing but 3:1 ratio. And 3:1 ratio basically specifies that if one person has got 1 marks, the other person has got 3 times of that particular person. Now the same thing cannot be measured in the previous one, right? In interval scale. See, if I have temperature like 10, 20, 30, see, when I try to calculate, or if I try to calculate the ratio of 30 to 10, right? This is also 3:1. But do you think this will be a proper value to probably say? Because see, at one point of time, if I say right now the temperature is 10 degree Fahrenheit, if I say 30 degree Fahrenheit, I'll not say that, hey, the temperature is 3 times more hotter or 3 times more colder. It cannot be like that, right? So in interval scale, we cannot consider this kind of things, right? We cannot say, hey, it is 3 times more or 4 times more with respect to the ratio. So here, it allows you to compare with respect to differences, but ratio cannot be measured. Ratio cannot be measured. One very important point. But in this case, ratio can be measured, right? So here I will go ahead and write ratio can be measured, because the type of parameters that we are using are like marks, or I can probably say some other information over here, right? So when I say marks, I can say, hey, one person is better than you because he has scored 3 times more than you, right? So this were about all the different types of scales. One better assignment that I really want to give it to you is that please try to assign like what all measurement scale we will specifically use. So let's say the first one is, if I want to calculate the length of different rivers in the world. So please let me know like what measurement scale you will specifically use, right? Then the second one that I really want to go ahead with is like favorite food based on gender. So for this, which scale I will use? Okay. Third, marital status. Which scale I will go ahead and use? Tell me. And then fourth, IQ measurement. IQ measurement is already told to you, right? We definitely will be using this ratio scales, because here you can use any kind of values. Obviously the order will matter over here, right? And if I just go ahead and talk about this particular definition with respect, the ratio scale is the most informative scale. It has all the properties of an interval scale. So all the properties that are available in the interval scale, that will be there, right? And it also includes a zero starting point, and it allows calculation of ratios, right? So these are some of the good examples. And again, here also I can probably take one more example with respect to this. This is nothing but weights. So in weights also you may have like 10 kgs, 20, 30, 40. I can calculate the difference. If I want to compare these two weights, I can say, hey, you are 3 times more heavier than this particular weight, right? Something like that. So their ratio is also calculated. If I talk about income is another one example, which is of a kind of a ratio scale itself, right? So here some may have a salary of 10,000, some may have a salary of 20,000, 30,000, 40,000, right? So I can say, hey, you are 4 times more, you are earning 4 times more than this specific person who's just earning 10,000, right? So all these informations were related to the different types of scales of measurement of data, right? And I hope you are able to understand the differences between interval scale, ordinal scale, nominal scale, what kind of data you specifically use in this, and all the other information, right? So I hope you like this particular video. This was it from my side. I will see you all in the next video. Thank you.